Assalamu alaikum friends. Friends, in this video we will learn about servo motor, how we can control in speed mode. First let's start a new project, servo control, servo integral control speed mode, and then click on create and go to open the project view, add new device. I have a model which is Siemens S7-1200, and that one CPU 1215C DC-DC relay, and that the article number version 4.4, and click enter. I laptop fonts are little big, I think so. If can control from here, no. Let's start. First of all, we will configure one thing. Okay, let's later I will tell you. First of all, we will start the program here. Go to the program blocks and to the menu B, and then start the project. First of all, I will take one internal memory bit here, and that name we can give M. We will start from M 100.0, and then output one coil I will take Q 0.0, because of that's my PLC S7-1200. This is the CPU 1215C DC-DC relay, that's all. And we like to start on speed mode. So let's second internal bit, that's not here, go here and take the branch and next, and that name I give 1 M 100.5 we can choose, and Q 0.1 is my forward speed, or any you can define it here for reverse or forward. If you like to be replace that tag names also, you can here go, and here you can servo FWT. That's we can change the tag name, that servo forward command, and that also you like to go and rename the tag servo reverse command, and then click on change. Your tag will be changed. Here you can also rename the tag start 0, and that's also you can change the name, rename the tag start 1. That's any tag name, you can change it here. Reverse also you can like it, but here forward also here. That's depend on your choice. In this line I will make after network will be too big, take another branch, and here we will use move command. But first of use the move command, first I will take one close contact here for mov move command, and here we can put any speed or something. Slow last step speed I will put 50, no problem. And that's the data register of QW64. Already in previous lecture I told you that QW64 is where coming. This is the output address of the analog output, because we are using our servo with speed mode with analog control of the PLC. In this model, CPU S7-1200 DC-DC relay have one input channel and one output channel. There is a two analog inputs and two analog outputs, and that's we will give the Q0.0, Q0.0. Also one more we will take when our Q0.0 on, also this speed will be moved to the QW64, and when our Q0.1, also we will take this one Q0.1 when closed condition, that speed will be moved to QW64. This also will choose close because of why this logic I am making for any when uh, servo runs, and which set point we will defined for servo, how much length for after or how much speed after our servo need to be close. That's same next in logic I will next row I will define you how we use this the Q0.0 and Q0.1. Because of Q0.0 is our forward command and Q0.1 is our reverse command. Let's hear one next row take. And here we will make also one more command for move command. For move command, here we have to be choose any data register where we can write the data for speed control. I choose MD10, and it's move into the QW64. That's when our Q0.0 will be on, after which command we will write it here, that will be moved here in QW64. That's why I make it here, because when stop mode coming, after that speed will be moved. In next row we will make one more row, we will take it here, and one open contact here take. And for smooth speeding, yani when we giving the analog signal, this large amount of bit or we can, if we set it by personal here from HMI or whatever, here we will make for thinking how to can smooth start of our servo. Let's use it here one another pulse, and next we will take it the here increment command, INC increment, and here we data choose take int, and here I will take MD40 to increment, and this one we will use for pulse. M0.1 I will choose for my clock pulse, and here any bit you can give. M200.0 I will take, no problem. And here when I say when my Q0.0 on, Q0.0 when on, after my pulses goes to the MD40. And one more I will take because I have a control for reverse and forward. I will take one more here branch, and I will take this one more Q0.1, and I will close this network to the, because of when Q0.0 on, after these pulses have to be generate that clock pulses to this data register MD40. And Q0.1 when all are this one or this one, if one of them relay will be on, after our pulses will be generated to the MD40. And that one thing, one important thing also I have to tell you, that M0.1, this is now in bit condition. When we using for clock pulse, that's we have to be define it here in the program. Go to the device configuration and go to the properties, and simply here system clock memory, that system clock memory we have to be define it here enable, and that's our M1.0 is the first scan this already, and also that enable this clock pulse. This may be you check mark or not, no, I think so, no need. But this is from M0.0, this is also our clock pulse, M0.1, M0.2, 0.3, 4, 5, 6 up to 7, yani different cycles have clock pulses. I choose M0.1, that 5 hertz clock pulse. That must be you have to be enable. If you not enable, that will be not, and also make it the compile, and here also can be checked, and go to back to the main OB, and that see that M0.1 is now he is saying M0.1 we have to be take from the clock pulse, that one, that M0.1. When we choose it from here, that's why not coming, because of we will again click and again take it here M0.1 for our tag 4. That's coming in bool condition, we no need bool condition. Can go to here our tags, program information, that PLC tags, that show all tags, that here we can see M0.1, this is the bool bit, we will delete this one. This is our 10 cycles clock pulse, and this is our 5 clock pulse. Because of this interrupting to the, now you can go to here M0.7, M0.1 we need, M0.1, now it will be accepted. Because of this first M0.1 interrupting, because this is the bit memory, we need that clock pulses, because when Q0.0 will be on, after one pulse generate to the and that MD40, and that's we will make it the pulse here, and also here you can give any M200.0 we will give. When increment coming here, our speed will be smoothly going to the QW64. So next here in this row we will make no problem, make it one branch here and make it the move command here. We move command, and here we will write MD40 moves to the MD10 because of here we're using that MD10 for what? For write the command to the QW64. How much speed we need for our servo, reverse or forward. So that pulses when giving increment. After that MD40 is here pulses coming. After this MD10 will be gives to the QW64, and that will be runs in speed mode. So let's check our program. This small. It will be take little took time because of you first initialize the program and then my now click enter not coming because of this my setting. Go to the setting and system, and that scale I have to be little make it small because of this my system is little height in the program. Then click load, continue, reinitialize or stop all, and then click again load. Click it finish and make the simulation on. And here that's we display format we will put in decimal. You can easily understand. Now our clock pulses, see our clock pulse is running, but here is why not increment coming, because of our Q0.0 is off. When it's coming on, after increment will be commit here, and that's also we will display format in the decimal condition. So let's check our program. I will start my first also we will take our camera, it's running. We'll make it little small. We can take it here, and let's make it the 0. So the program is successfully running, and see now what's happened for about this clock pulse. Now our Q0.0 is on. When on, it's here increment coming at MD40, and MD40 is moving the value to MD10. So our speed will be increased slowly. And if we like to control the speed, first of all, and this why we used when this will be on, when this will be off, yani in stop condition, after move 0 to our QW64. Now you can understand about this 2 bits of how I take. This is any end when Q0.0 and Q0.1 is in close condition, that's 50 speed move to an QW64. because of if this is going to increased after it's going very high speed, and now it's start from also this speed and make it 0, and that MD40 ever. One more thing, when we like to automatically stop the command, first we will stop the simulation, and here when we more make one network, and we will use that equal that's command we will choose and make it in D int. Here we will use MD40 when is greater, and here we will take MD500 to set the value how much we need the speed, and here we will take the M100.0 M100.0 to goes to the reset condition, and here also take one branch, and one more will take M100.5 will be goes to reset, and here we will put one any value of the set point, how much speed after we will like to close, and again download to the PLC, and then click load. Make the simulation on, and let's here we have to be give any value. For example, we will give 100. When our speed increase that 100, after this will be stop. 0, we will put one set MD40 0. This one we have to be right here, something wrong, stop simulation, and this we have to be MD40 we have to be choose, not a MD directly. If we move the value, it will be not stop. You have to be choose this data register, which data register when you choosing the write the value, this data register you have to be first close, and we are putting the data increment data at the MD40, that we have to be move the 50 speed to the MD40, and let's simulation on and make it monitor 1, Now see, our speed is set point we put at 100. When it goes to the 100, after our motor have to be must be go to stop. See, now our 100.0 is stopped. Our camera is why stopped. We'll check later. Yeah, now it's connected. See, we put 100. We put it here, for example, 150. Any speed when we write it here after this command 100. See, when we start the on, it will be starts very smoothly. See, and 78, 84, 86, 89. This is speed slowly increasing. And when it's reach at its set point 150, it will be reset this M0.0, and that 50 which we choose it here, it will be forward to the MD40. That's command we will use, that compare command. In previous lectures already I discussed about this command, how to use in the program. So I hope you understand this program. And now we have to be check in reverse condition also. Goes to the start, and now our speed is increasing in reverse condition 78, 86, and as it goes to this value 150, this will be reset the M0.5, M100.5. See, when it's going, and this if you need little more, you can put it here 200, can make it here same like, and again you write. This is now when you go to in reverse condition or forward condition. Any condition when you choose, that command will be worked for both, yani M100.0 and 100.5. This is your start command of your servo. See, when it's reach at the 200, it will be reset your M100.0. Right? And also this set point will be working, and after our this command works for this 50 speed, we will write it here 50. If you like to change this speed also, you like to from 0 start, yani for 10 I think so, but 10 speed will be not work because of this 4 to 20 milliamps starts from 50 or 60. Again download this, not I put any data, just if you like to continuously change it from here, any speed you like to be change in the servo, here you can put any data registers, look like any MD10 I put for here writing. Here you can put an MD20, MD30, MD50 or which speed, and see now when we start it will be forward 10 speed when it will be stopped at your pinpoint set point. This the 200 is our set point. When it's reached the 200, it will be after again moves the 10 speed of the servo. 100, 13, 15, 20, 60, 36, 41, right? 150, 166, 70, and 200 is our set point, right? 197, 200. And as it stopped, yani Q0.0 or your Q0.1 will be stopped, that value will be moved to your servo. This also when you start, this smoothly start your servo from 0. If I can make big, little you can see it slowly start the speed, and when it's reach the set point, it will be stopped. Slowly your speed will be increased, and when it's reached the set point 200, it will be stopped, right? And also, when you like to this all data, this set points, this speed, I will show you, no problem. Stop here, and we will take it here. MD, but must be see here which data registers you used. MD10 used, 40 used, 40, 500, MD600 we will use, no problem. And again download to the PLC. Click load. And see now, make a simulation now. And here when you write it 15 for example, that will be moved after 15. See when we start 1, 98, 100. Our set point is 200. See when our 200 reach at the set point of 200, and now value moves the 15. And here now no need to be stop simulation, or you have to be go back or again download to the PLC. You can simply click it here, and you can choose it here which value you like to be forward in the MD40. This will be move forward, and this also which value you like to be change it here. For example, you like to be 300, and click it OK, and it will be works for 300. Which set point you needs, that set points will work with your servo. And many ways have to be to control the servo motors, for also that speed mode with position, jog mode with position 230, 40. It will be goes when 300, after it will be stopped. Speed will be increased slowly, not any torque coming. When reach at the 300, it will be stopped, and your 50 value will be moved back to your MD40. And that data register simply you can pick from here, and you can take it the HMI. Inshallah will be next lecture. I will show you how this data registers you can move to your HMI, and you can make set point from your HMI. Till then, keep watching. Please like and subscribe my channel. Thanks for watching. Allah Hafiz.